Okay, hello everyone. I will be going through the question Treasure Trove today. Before I start with this walkthrough, there are some prerequisites. So it is recommended that you use a Linux system such as Parrot or Kali. I'm using Kali because, everyone has it, or I hope you do. And also because one of the tools that I'll be using is only available in Kali, or I would say in Linux. It's called StagSeek, and I'll get to that later on. But that's one prerequisite. The other would be some basic knowledge about John the Ripper and about just in general image steganography. So if you do not know these things, maybe you can read up a bit and you can come back to this video. Okay, let's get started. This is the zip file that is distributed in the platform. So let's just open it up and let's just move it over here. Okay, no problems. So we are given 3 files. All right. Let's start with this txt file. It looks interesting. Well, right off the bat, you can see that John is mentioned. And anytime John is mentioned, you may want to think about John the Ripper, which is the tool that, allows us to brute force pretty much anything from zip files to Word documents. And in this case, we're given a 7-zip. That's just named level 2. So this is interesting as well. But as you can see, it is password protected. And there's also level 3 that's 7-zip. So, given this hint, we can conclude that we should use John the Ripper. But before we use John, we have to actually get the hash of this 7-zip file. The hash, well, is technically not a hash of the file, but a hash that is specific to John the Ripper itself. And therefore, we have to use a special tool called 7-zip to John. Over here, you can specify the file. And if you don't pass it to a file, we'll just get this. We don't really need to know what this is about. So instead, we should store this into a file. Let's just call it hash. And as you can see, it's over here in hash. If you try to open it up, you'll see the same thing. It's pretty big, so it might crash your text editor, just like mine. So while this is loading up, the next thing we can do is actually pass this hash, or the contents of this hash, into John the Ripper itself, and get to work. As you can see, the hash is quite big and it's crashing my screen. So I recommend not to open it up. As you can see, we don't really know what it says, but John the Ripper does, and that's why it matters. So John the Ripper just goes by John, and we can pass in the hash file. And we can pass in a word list, which is basically just a list of, predefined passwords that we should use against this password protected file. Well, I'm going to choose this specific one right here. It comes with the Kali distribution, I believe in Parrot OS as well. And the reason I chose the rockq.txt file, despite it being the largest word list that's available, is that many of these CTF authors may use the rockq.txt to get a random password to use for, let's say, encrypting something. Well, usually the password for a brute force question would be found probably the first 1,000 entries of rockq.txt, so it's a good way to start. Well, I've actually cracked this hash before, but if you haven't cracked it, because I wanted to save some time, if you have cracked it, you can just do this, just to show. Well, it may take you a while, depending on your PC specs, but after maybe, let's say, a minute or so, this would appear on your screen after this command. For me, I've just cracked it for you guys. So we see that the password for this zip file is actually password 123. Let's give it a shot. Now we can move on to the next level. Over here, we're given level 3, which is also password protected. And we're given 4 files. Let's start off with a text file. Okay, it says that only JPEG files are allowed and he doesn't know what's going on, and it's from Bob. So looking at the profile pic that he may have tried to upload, it seems that there's 2 of them. And indeed, one of them is larger, so we may want to focus on this file instead. Well, here's a resume, but it's not really that useful to us. So let's begin with, our standard procedures for JPEG files. Let's just exif through them to see if there's anything interesting. Well, we see that there's nothing much that we can get. There's no comments for us. Maybe we can check whether the file itself has any flags. Maybe let's just open this in a hex editor if you have one. But if not, you can just get the entire file itself and just pass it to Tail. Well, you can see that there's not much info at all. So we can presume that because it's a JPEG file, well, one possible method of hiding data would be this tool called stack hide. And the thing with stack hide is that it's not on my machine, but I used it to create a question. Well, you can use stack hide to hide data within JPEG files, such that it cannot be seen as plain text in it. So it's not just appending the data into the back of the JPEG file, but actually incorporating it into the image, making it useful because it hides it from, let's say, bin walking it. It won't show up as a separate file, and in this case, I've actually put a text file inside this JPEG. So if you're familiar with stack hide, you know that it requires a password or a passkey, but we actually don't know what the passkey is. Well, if you have the resources, there is this tool called stackseek. And what stackseek does is actually just brute forces or uses a dictionary of, passwords, just like the rocky.txt file, and goes through each one of them to decrypt profile to the JPEG for us, so that we can save time and not try to, find the flag. Maybe it's a common password and we can just plop it in over here. Well, this will take a default word list, but you can specify your own. But let's just see. Oh, that was quick. So it found a passphrase, banana, and it extracted it to this output file over here. Open it up, we get this piece of string. And to the trained eye, you can easily recognize that this is base 64. So in our command line, we can just base 64 /d for the decode file, and we can just specify a file name over here, giving us this message in our terminal. So this is a letter from Bob, the same one from this IT stuff txt. He's been the main character of this question so far, and you can see that there's a password over here that we can actually use. So let us just take this and presume that this is the password for this one. Well, indeed it is. And we're at the final level. Well, before the actual company secrets, which is the flag itself. Reading the txt file, we see that, this company lost their company keys. It may be a reference to maybe a passkey or a password for maybe the next question. And we can't access these things. There is a backup table that stores hashes for the company keys. Maybe looking at these hashes may give us an actual plain text value. You could probably use CrackStation to decode each and every one of them and try to find out which is the actual password for this company secrets. Well, you can try brute forcing this, but I've set the password to be quite long and unbrute forceable. Let's look at the backup table itself. Well, Caddy doesn't come with LibreOffice. You can install it, or you can open it up using some other method. But for the sake of demonstration, I've installed this. Oh, we can see there's 10 entries from Bob, Stuart, Kevin, James, Richard, can't really do anything, except maybe take each and every one of these and try to find its reverse, or try to find the plaintext associated with it. And in this case, you can actually refer to another table, which you can find inside company secrets. It says there's a letter called Dear Richard. And to me, this signals that maybe we should focus on Richard and actually try to look up his hash instead. So we can go back to that Excel file. Maybe let's take Richard's hash and copy it. Now we learned from previous CTFs that there's a tool called CrackStation. So let me just open it up in Firefox. There's a website called CrackStation that allows you to just perform reverse lookups. And I have it over here. Let's paste it in right here. Sorry if I have copied it over. Let me just copy it again. And crack it. Oh, it's a pretty good secret over here. If you have used John the Ripper for this, good job to you. But I guess this is more fun. So continuing on with the challenge. Now that we have my secret, you can actually try to decrypt this or extract it. And there we go. This is the Dear Richard TXT file. And it's from Stuart this time. It's not really interesting. So let's just move on. There's a PNG file, a bit more useful to us because PNG files are pretty much one of the most common files that we can hide data in, apart from JPEG, of course, and notes.txt. If you have reached this level, good job. And there is actually one more piece of steganography left for you to find out. This might be new to everyone, but for some it may be old news. So as with PNG files, let's just exit to it. You find anything. We see that there's nothing in this PNG file, and there's a good chance there's not much data in it as well. So let's go through each and every one of the files instead. Since there's only 3 files that we can work with, which is Dear Richard and notes.txt. If I've gotten to this stage, I would open up my CyberChef real quick on Firefox, because this allows me to see something that I always look out for when looking at text files, which is something called Unicode. It is a pretty useful way, a pretty novel way of working or like stenography in general. I've only heard about it this year, and the purpose of including it in this challenge is to also share with you guys about this method. So let's take Dear Richard for example. Plop it in here. We see it's pretty normal. The output is nothing to worry about. Dear Richard, we're happy to announce. It's the same message we saw. 500 bytes. Now we go into over here, notes.txt. Seems like 2000 bytes. But seems that there's not much actual characters. So why does it take so much bytes? As you can see, there's a bunch of dots over here. They are pretty irregular in length. Some are long, some are short, and there's like no specific pattern or number it follows. That's because this type of hiding data is something called Unicode steganography, and it is a way of hiding data within actual text files itself, or any files that has Unicode in it. The way this works is, these dots actually represent a character that has a width of 0. So when you open it up in your notepad, it's actually there. The characters are over here, all those dots. But those dots actually represent a character that's the width of 0. So instead of actually selecting maybe 3 characters over here, there might be like 12 characters, or maybe like 9 of them have 0 width. And this is called 0 width steganography. It's a specific type of Unicode steganography. There are other characters in the Unicode table that people use to hide data. But for this one, it is quite convenient because there are a bunch of tools for 0 width steganography. Just searching it up over here yields the result. The first one should do, or you can look at the others. And you can see that this is an example. So the text "where am I" is actually over here. But let's say we decode it, we get back the same one. So let's try putting our nodes.txt over here. Remember to press Ctrl-A to actually select those 0 width characters, as you may actually accidentally leave out a few characters. Ctrl-A and paste it over here. And press decode. As you can see, there's this original text, which should only be around 400 bytes. But instead our text is 900 bytes. Those extra bytes comes from the 0 width characters, forming a form of encoding in itself on top of Unicode, and giving us a hidden text of length 67. Well, you can see the flag is over here. I have included some padding in case any one of you actually accidentally missed a few of those 0 width characters. I hope this Unicode steganography concept is a new concept to you all and that you can actually use it in real life when you try to hide data in maybe a innocent looking text file. Without, as we have seen, there's the flag over here, and this is the end of the walkthrough. I hope the methods that are taught in this simple walkthrough are interesting and you may want to explore more on your own. Feel free to do so, and do not be afraid to contact us for any other questions about this question. And thank you and see you again.